Welcome to cryptography session. Here I am going to give an overview of a network security model. So this is the overall or a generalized network security model diagram. Here the left side part is controlled by a sender and the right side part of this diagram is controlled by the recipient. So here message means a normal message or original message. Another name for this original message is called as plain text. So a sender is trying to convert that original message or a plain text into a secured message. So the secured message another name is ciphertext. So a sender is trying to convert a plain text into ciphertext with the help of secret information. So other name for secret information is a key. So a process of converting plain text into ciphertext by the usage of key is called encryption. So we should assume that encryption is done at sender side. And if that secured message is transferred through an information channel, so this informational channel may be an wired medium or a wireless medium. And at the receiver side, the secure message was received by the receiver. But the original message cannot be able to identified from the secured message by the receiver. So there is a need of converting that secured message into an original message. So the process of converting that ciphertext into plain text with the usage of key is called as decryption. So the decryption process is done at the receiver side. If the same key is used at both sender side and receiver side, means for example, if the sender used the key value as an integer value 3, so the same 3 number is used as a key at receiver side, means those type of encryption model is called as symmetric encryption. If different keys are used, that means sender use one type of key, receiver use another type of key, means that type of encryption model is called asymmetric encryption. For controlling sender and receiver's processing, there is a need of a third person. So the name of the third person is called as trusted third party. He also be called as arbiter. So the functionality of trusted third party is used to control the behavior of both sender and receiver, and he may able to give the secret key to both sender and receiver. And here attacker role is the attacker may able to hack the information via an information channel during the transmission. So the main job of attacker is to obtain a key from the secret information or to retrieve the relevant or related plain text from the given ciphertext. So the overview of this processing is generally called as a network security model. So message or an plain text is transferred from one party to another party. So a person who sent the message is called sender. A person who received that message is called as receiver. So this transmission may be sent via an wired medium or a wireless medium. So there may be the possibility of internet service also provided for transmission. So the information channel is established only for defining the path via an internet from source to destination. There are various security aspects are used for protection of that secured information. So there are two main components are available in a network security model. The first component is all the security related transformation of information that should be sent consequently and logically by a secret security algorithm. And a secret information which is shared between two end parties. Here, N parties are denoted as both sender and receiver. So, any secret information shared between two entities means that should be unknown to opponent, which means that an attacker cannot be able to break that secret information. For that purpose only, we should design the network security model. The role of trusted third party is needed for secure transformation. So that trusted party should be responsible for distribution of secret information between two end parties, and that secret information should be kept secret from opponent. So the overall processing of these step-by-step model is a network security model. And if we consider security services, there are 6 types of services are available, which were all discussed in previous session. So totally 6 types of services are available: confidentiality, integrity, authentication, access control, availability, and non-repudiation. And there is a need of designing these security services by the following tasks. So what all the tasks means? The first task is we should design an algorithm for secure transformation. That means that algorithm should not be defeated by opponent. So for that purpose, we should design a secured algorithm, and that algorithm should not be broken by an opponent. For that purpose, we should design the algorithm. And second task is we should generate a secret information, and that secret information to be used with the specific designed algorithm. So using that algorithm only, we should be able to generate a secret information. So this is the second task. So after designing algorithm, we try to convert the original message into secret information. Then third method is we should develop several methods for sharing that secret information from sender to receiver. So in what all the way the secret information may be kept secret from sender to receiver. So we should apply different methods in a step-by-step manner. And the fourth task is there is a need of specifying a protocol, and that protocol should be used between those two parties in a secure manner. So here the security protocol means the information channel selection. So there are different type of protocol mechanisms are available, which are all used for finding the best path for transformation of information. So these 4 main tasks that should be considered for designing this security services. And there may be the possibility of threats in a security model, because the cryptanalysis or a cryptography mechanism is only used for providing a secured model, but there may be the possibility of threats in it. So I already give the difference between threats and attacks. Threat means it will harm the system. Attack means it's not necessary to harm the system. That means threat is more danger than attack. So there may be the possibility of 2 types of threats. The first one is information access threat. So what is the basic concept of information access threat? Means there is an interception or modification of secret data on behalf of an authorized user. So instead of an authorized user, an unauthorized person may able to alter few informations on a original data, and that unauthorized user does not have a right to access that particular data. So this type of threats is done by a human being. So example for that information access threat is a hacker. So if any hacker do threats, so those type of threats are called as information access threats. And the second technique is service threats, which means that it exploits different type of services that may flaw in a computer, and that may be inhibited by the legitimate users. which means that, for example, if an authorized user trying to install one application in a particular resource, so if an application contains virus or worms, it will be disturbed the system, and that software is only installed by a authorized user. But that authorized person does not aware of the virus or worms present on that particular application. So this type of threats are called service threats. So threats are, it will danger and it will harmful the system. So if any threats is done by a human being, that is called as information access threats, or if any threat is done by worms or viruses, then that is called as service threats. And another name for service threats is a software attack. So if any virus or worms do attacks in a system, those type of attacks are called as software attacks. So it is created and introduced in a system via secondary storage devices and via an unwanted logical code. So in this way only virus or worms are defaultly installed in a system. And for avoiding these type of threats, there is a need of designing a better security mechanism. In two ways, we can able to trying to design it. One is a gatekeeper function. The role of gatekeeper is he should aware of the person who is coming inside the particular environment. So he should aware of it. So gatekeeper function means before entering an authorized person's usage, we should get their password or a PIN number for identifying those authorized person's identity. So the best example is a password-based login procedure for accessing the resource. So these type of functions are comes under gatekeeper function. And there is a need of internal control monitoring. So if any authorized persons are available in a distributed environment, all the client's activity should be monitored and controlled by the server. So time to time we should analysis what are the activities that can be done by the authorized users in an environment. In that also we can able to control the for avoiding these type of threats. And this is an overview of OSI security architecture. So these topics were already discussed in previous sessions. So I just give the overall idea in a diagrammatical way. So in an OSI architecture, there are three type of components are available. One is services, attacks, mechanisms. Services, six type of services are there: confidentiality, integrity, authentication, access control, non-repudiation, availability. Attacks two types: active, passive. Those are all depending upon cryptanalytic, non-cryptanalytic. Here four types of attacks: ciphertext only, known plaintext, chosen plaintext, chosen ciphertext. Non-cryptanalytic attacks are for breaking confidentiality, integrity, and availability, which have some subdivision techniques in it. And there are 7 or 8 different security mechanisms are available. These techniques are supported the services. And there are few terminologies are available in a basic encryption model. So these terminologies will be discussed in next session. Thank you.